For this next project, we're going to make a game. We'll have two buttons, one for a person on the left and another button for the person on the right. And we'll have a row of LEDs on the left for this button and a row of LEDs for this button. The object of the game is to push the button as fast as you can, and the person that pushes the button the most times and the fastest wins. And then it starts over again. Along the way, we will learn how to create global variables, create reusable, compact programming techniques. I will introduce you to arrays, and we'll introduce encapsulated routines. First, we need to construct the circuit, as you see here. Two buttons. We'll be using two ports, port B and port D, a row of LEDs that has a row of resistors, and another row of LEDs that has a row of resistors. I'm not really introducing anything new here in this circuit, but I'm going to draw it out anyway. We're going to have 7 LEDs with 7 resistors, and we're going to have a button on port B. And these resistors are going to be the same as before, 330 ohms. We're going to repeat this same on all of these pins, 1, 2, 3, 4, 5, 6, and 7. But the 7th one actually is a little bit different because we have a red LED at the end. And I'm using 390 ohms of resistance. On the 8th pin, which is right here, we're going to put our button, as we did before. We are doing software debouncing, so we're not going to use a capacitor. On the Atmega32, port D actually has 7 of the pins here and the last pin on the other side. The setup is going to be pretty much the same. You're going to have 7 LEDs, and then on the other side, which is pin 8 for the port D, we'll have the button. So let's go ahead and count this out. 1, 2, 3, 4, 5, 6, 7. We have LEDs, and each one of these are the same, 330. You can have a greater level of resistance. It's just going to have a dimmer LED. And then this one is the red one. And then over here, on this pin on the other side, we'll have the other button. And this button is for this set of LEDs. And this button is for this set of LEDs. On the breadboard, I'm going to start with the resistor because I want to make sure that I'm getting a good seating. And what I'm doing is I'm just going from row to row. So I'm going to put a wire from the first one to here, and then the LED is going to go from here to the ground. Okay. Actually, I'm going to do it the other way. I'm going to put it in this direction here, since it's going to be easier for me to wire this circuit. Okay, so now I can put this wire, here, and so now I have a wire going from pin 1 to the first LED resistor, and then I put the first LED in, and the short lead is the negative, so I can put it here and here. We're going to do the same thing with the rest of the resistors and LEDs. We're going to put another resistor here and then add another resistor or an LED. We're just going to use the next 2 rows. I'll put the next wire and then a resistor and an LED. So do this for the remaining LEDs. And now I'm going to use the 390 ohm resistor for the red one. Oh, this actually I have another green. Wait. Yeah, I have another green. But I ran out of resistors anyway, so I'm going to have to use the 390 for the green one as well. And now for the red. Resistor. And the red one. Okay, that's the first row. Do the same thing with the port D. Do the same thing for port D. And port D starts at, let's see, 1, 2, 3, 4, 5, 6, 7. On number 14. Number 14. Remember that the negative is actually on this outside rail, so don't get that mixed up, because on the other side it's on the inside, so it's easy to forget. It's on the blue side. What? Now we will add the button switches. Use one of these little guys here. We're just gonna put it in a clear area. We'll put it as far to the side as possible so it can be as far from the opponent as possible. So we'll put it all the way to the edge here. And we'll put the other button to this side. Yep, let's make it at the same row. Okay. Okay. So we need to take one of the legs of this button to this pin number, or the 8th pin, or pin number 7 for port B. Just connect it to the first leg, or the first lead. And then we'll need to take the other lead to ground. So we'll take this one. Okay, so now that's going to ground. Now we're going to do the same thing with this. And this is just a short length of wire here, because it's going to port D pin 7, which is on this other side. Alright. And then the ground. Let's get into Programmer's Notepad.
Okay.
I changed the code to only have a skeleton of what we need. So we're going to go to the open and the LED on again. Go into main. And you can see that I only have a few things here. It's the include statement for the AVR IOH. This is standard for all microcontrollers. And I kept the delay in here because we're going to be using the delay in the winning side of the LED. We have our main routine here, and we have our infinite loop here. You can see our main routine has the block brackets for the block of code that's going to be inside of the main. And then we have the while, which has its block brackets. We don't have any information, or we don't have any instructions within this block of brackets yet, but we will in a little while. I gave you a very small taste of what variables are on the last video. Now I want to explain variables in a little bit more depth. A variable is simply a container that has two main attributes. One is the size of the container and what is inside the container. The stuff that's inside the container could be classified as two different things, and that could be the number of things that's in the container or the type of stuff that's in the container. The easiest way to think of what a variable is think of it as a basket. This basket has a size, and the basket also has the number of things that are inside the basket. For instance, a real-world scenario would be a basket for apples. The basket could be sort of a medium-sized basket that can hold as much as 10 apples. So we now understand that the basket has a size. It has a maximum capacity of 10 apples. The thing that's inside the basket are apples. That's a type of thing. And we have a number of apples inside the basket. In the last program, we used a variable called pressed confidence level. And this pressed confidence level was an integer. The integer is the type of things that are going into the variable. And in this basic sense of a variable, the integer, or int, also determines its size, or the size of the basket. In some programming languages, you need to specify what's inside the variable, or what's inside this basket. In this GCC compiler, you don't need to actually put in a number to specify the contents, because it defaults as 0. So essentially doing this, just equaling to 0, this is done by default. But if you want it to be a different number by default, you can actually specify that in the declaration of this variable. And what I've just typed here is that very declaration. You're declaring a variable by specifying its size, the contents of this variable, and what type of thing is going into this variable, or what type of thing is going into this basket. There are many variable types, and even ones that you can define yourself. Basically, there's variable types like char, or char, which is one character. There's string, which is multiple characters. Int, integer. There's a signed integer, unsigned integer, which means if it has the ability to go into the negative region. Integers, just like in basic math, does not have any decimal places. And to further determine the size of the basket, you can create a dimensional array, or just create an array. And that would essentially be multiple baskets and in various dimensions. In the AVR GCC, you have a couple special variable types, and that is 8-bit integers and 16-bit integers. The 16-bit integers have the ability to have a higher number than the 8-bit. The number of bits, if we could go into binary notation and its arithmetic, but the number of bits determines how high a number will go. It's very similar to decimal, or to base 10, which is our standard numeric system. And the number of zeros after a 1 would essentially specify a larger number. You won't really need to worry about a lot of that complex information I just specified with bases and binary. You've learned a little bit about binary already, but once you get into the advanced level, that is not really necessary for the stuff that we're going to be doing here. I'm going to keep this variable in here because I know we're going to need it later, but I'm not going to initialize it to 1, so I'm going to let it be default at 0. I'm going to put in some comments of what I would like to happen in this program, and this is also considered like pseudocode. Pseudocode is essentially readable code, or readable instructions that would be able to be read just by reading it by a lay person. So I'm going to just put in something here. This is going to be my initialization area. Setting up ports. Okay, so, and in here I'm going to process the button. And we have two buttons, so we're going to have button clicks, and we have LEDs, and we're going to use port B and port D. So let's go ahead and clicks for, let's say, side 1, and process button clicks for side 2. It's easy to get really complex very fast in this programming, so I'm going to introduce what is called encapsulation. It's essentially code that would be used multiple times for the same thing. We don't have to actually code it multiple times. We put it into another area, another code block, and we execute it the same set of instructions for two different processes that we have. And that sounds a little bit complex for now, but by example you'll see what I'm talking about. In the previous program we had a conditional statement that was like this. If button was pressed, then it did something, else do something else. In this case we're going to have to do two things. Actually, let me make these comments do something, and then so it doesn't think it's an actual command or function. Okay. In this particular case, before we had only one button, so we had only the need for only one conditional statement, or if-then statement, if-else statement. This time we're going to need two. So let's go up here actually and say, by the way, there's two ways of making comments, and that's using the double forward slashes or using a forward slash and asterisk to specify a particular area of comments. So button was pressed for side 1. Let's say that. And then over here, button was pressed for side 2, which is the opponent's side. Let's say do something. And then over here we do else, do something else. Alright, so let's clarify it a little bit more. Okay, so when the button was pressed for side 1, let's say what we're going to be doing is we're going to be lighting up LEDs on port B one at a time. And then over here, this is just making sure that the button was released. Okay, and over here it's going to be lighting up LED, I say LEDs on port D one at a time. And this one would say making sure that the button on side 2 was released. This one is on side 1. Okay, so we kind of know what we want to do, but I want to not sort of confuse this the main procedure. I would like all the instructions for internally in these conditional statements to be somewhere else. I don't really want them to be here, and I want it to act like it's a command that does this. So this is the first part of encapsulation. I'm going to just tell it to do something, and then it'll go somewhere else and run all of those individual instructions. But before I do that, I need to introduce you to arrays. And we're going to be using arrays because we have two buttons and we have two sets of LEDs. And we're going to have an array of two. Let's say, for instance, we're going to have a pressed basket. We had pressed B before because we were pressing, or we just had a pressed variable before because we only had one button and we only cared if it was being pressed or not. But now we have two buttons, and we could call it pressed B for port B and another one for pressed D for port D, because the buttons are going to be on port B and port D. We're going to make an array, so it can be, we're going to have two baskets of pressed, and that would be pressed 0 and pressed 1. 0 would be the one on port B, and pressed 1 would be on port D. So let's go ahead and declare that variable. And you may have already noticed that I'm putting my variables outside of the main code block. And what I'm doing is creating global variables. So this is how we declare an array, a variable array. So I'm putting an int. We're using an integer, and it's called pressed. And we'll be putting 2 in brackets, and the brackets represent the capacity of the array, or the highest or maximum number of baskets, so to speak, for this array. We will also do this for pressed confidence level. We'll have the brackets with 2, because we're going to have to eliminate the bounds in software. So we're going to do the same thing that we did before, debouncing in software. And we're going to do the same thing with released confidence level and use the same brackets. And now we need to introduce a new variable, and I'm going to call that LED number. And this is going to represent which LED is being lit up. We're going to, an LED number, we're going to have essentially 0 through 6 because we only have 7 LEDs. We will need to know which number needs to be lit up next. And we use the array of 2. This is an integer, so the LED numbers can go up to quite a high number. But we have 2 sets of that. For the rest of the programming within the main subroutine, I want to make sure that any code that I'm going to write is not going to be duplicated or needs to be duplicated. The code that I'm going to be writing, if it's going to be unique, I can go ahead and write the code in the main routine. But if it's not going to be unique, if there's multiple times I'm going to be writing this code, I might as well make the code in another code block and call that code block whenever I need it. The initialization for the LEDs and the button is only going to be done once, so I'm going to go ahead and write that code into the main block. So we will start out with defining our data direction registers for port B. For code compactness, I'm just going to go ahead and write this in binary form. So DDRB, we know that's data direction register for port B, and that's going to be equal to, I'm just going to go ahead and make it equal to B0 because I know that the number 8 pin or the pin number 7 is going to be input, and then the rest of them are going to be output because those are the LEDs. So let's do 7 more ones. Okay, so that's done. And then the data direction register for port D is going to be the same thing because I'm using the button on the same pin number for port D. I could have actually made a variable equal this particular binary number and then just assign that particular variable to both of these data direction registers, but there's really no need for that in this really small program. In more complex programs, that could be used for better documentation within the program, so you know what that sort of means. In the previous program, we set the button pin number pin 7, or the 8th pin. We set that to a high reading because when there's a high reading, the button is not pressed, and when we press the button, it syncs to ground, and then the button reads a 0 volts. So we're going to go ahead and set that up. Port B, we could write that as, because we want all of our LEDs to be off when we first start, so we could actually make the port B at a high reading for the input or the button, and then the rest of them can be 0. So all the LEDs are off in the beginning of the program. We could have done it this way. Let me write the port D as the other technique, which is shifting pin 7, and that would have given us the same result. For consistency, I'm going to write it in longhand, just like the one above it. Okay, now that we have our initialization set up, we can go ahead and sort of clean up our conditional statements here. I'm just going to remove this and insert our actual code. Bit is clear, and this is going to be pin B, comma 7, and that's just like the previous program. We're reading the 7th pin on port B, and we're going to do the same thing to the second block of conditional statements. Bit is clear, and this is pin D and 7. Probably should have taken this out a while ago. Okay, so now this is where things get interesting, and we're going to start our process on making the code encapsulated and easier to read. You're going to see that the code that is required here to process the button and light up the LEDs is going to be the same code as would be in this location. The only difference is we're requiring the variables to be either a 0 on this side and a 1 on this side. The same thing is true for the else statements, because releasing the button and pressing the button it's going to be using the same part of the array. I'm going to go ahead and write the necessary code that would be in this portion of the conditional statement, and you will see the portion of this that needs to change to be a part of the next conditional statement. And you'll also see how clear it will be to separate that code into another code block and call that code block and only specifying the number, the array number, which is either a 0 or a 1. If you remember, we had in this portion pressed was equal to 0. Since we're working with an array, we're going to go ahead and put a 0 in this bracket because we're talking about button number 0 in this case. And in this one we had pressed is equal to 1. And we're using the 0 again because this is which button we're talking about. And this was only allowed to be 1 is if it went to 0 prior to this. So this was going to be contained in another if-then statement, or an if conditional statement. If pressed 0 button was equal to 0 first, then it was allowed to be pressed 1. It was allowed to be equal to 1. I'm going to go ahead and use my traditional brackets here. And we also set up our debounce variables, and that was pressed confidence level, and this is the 0 button, and we incremented it. And then what we did is we contained this block of code in a conditional statement that tested the confidence level to be above 500. And we're talking about button 0 here. It's greater than 500. And we're going to contain this information we have here as we did in the previous program. And you might have noticed that I put double equals here. This is a test for true or false. That's when you use the double equals. When you're using a single equals, you're assigning a string or a number to a variable. So the single equals is an assignment operation, and a double equals is a true or false operation. It's a logical operation. If you don't use double equals here and it's just a single equal sign, then you're going to get unexpected results. This is one of the things that always trips me up in programming. I always have to look for places that I forgot to put the double equals, and this is something you really want to keep your eye on. Already you can see where just changing this 0 to 1 will allow this whole set of code to be used in this area for the other button and LEDs. Let's make sure that we 0 our confidence level once it has been achieved, so we can start that whole process over again. Is equal to 0. And now we can go ahead and add the code to our else, which is we have the released confidence level, and we're incrementing that every time we know that it's good. And if the released confidence level of button 0 is greater than 500, then we can go ahead and process the pressed equal to 0, and we can 0 out our confidence level again to start the process over. Is equal to 0. I'm assigning 0 to that, and I see a place where I probably get an error, so I better put that as a capital R, and then I'm going to close my braces here, this code block. This is the area that we are very confident that the button was pressed, so this is actually where we're going to be putting in most of our LED lighting up. So what we want to do is we want to start turning on LEDs once we know the button is pressed. So this is where I'm going to be increasing the LED number, ++, and well, actually I forgot the array here. And this, you would be tempted to actually just plug this number into the port B for the LEDs. And you could do that. It would just take a lot longer for you to get up to the last LED, because it is actually counting up in binary if you do that. If you apply the LED number 0 to all of the LEDs, the 7 LEDs that we have, then the LEDs would actually show you the number in binary, and as you press it, you'd see the LEDs light up in a binary sequence. We don't want that to happen. We want it to light up one after another, so we would only have to hit the button 7 times to be able to win on one side. The other way, for 7 LEDs, it would be 64 button presses to be able to get up to the top. So let's go ahead and invoke our bitwise operations that we learned in one of the initial videos on how to do this. And this is the same thing as shifting in the bitwise operation using the OR and the shift operation. So here we go. Port B, we're going to OR equals 1, and then the shift operation, the LED number, array of 0, because that's our LED and button set, and that should give us a sequence from the first LED all the way up, and it will keep going even past the 7. So what we need to do is we are going to need to have another conditional statement that says if anything is above 6, then that side wins. So let's go ahead and add that conditional statement in. If LED number of 0 is greater than 6, then we're going to have to write some code on what it does when somebody wins. And I'm thinking we're just going to flash that side, the whole array of LEDs. So let's just put in here a little bit of pseudocode comment. Port B is winner, and blink or do something else. Okay, so now I'm going to take a lot of this code and just start to separate it out into chunks of code that is outside of the main procedure. There are 3 things we need to do this. First, we need to create what is called a prototype of this block of code. Then we need to create the actual block of code. It's going to look almost exactly like the prototype, but it'll actually have the code within that block. And then we need to call this code. So let's go ahead and make our prototype first. We have to make it on the top. This is the way in C++ or C that you have to create prototypes. And I'm going to start writing it in. Void process pressed button. And then I'm going to have it pass in a variable. So I'm going to call this button press, and this will be either a 0 or a 1. And we're going to go ahead and end this statement with a semicolon, and then on the bottom we're going to go ahead and add it in after the main. We could have actually done away with the prototype and just put the whole block of code on the top, but it becomes very difficult to read what's going on in main, and main would eventually get all the way to the bottom of the code, and I like to have the main block of code near the top. You'll also notice that I use a word called void, and then you probably saw this in one of my initial programs when I used it with main. But this just means that we're not returning anything from this block of code. That means I'm not expecting this block of code to tell me anything. I'm just expecting it to do something and not give me any sort of numbers or values that I could use in further processing. So I'm going to go ahead and copy this block of code, or this line, and I'm going to add it to the bottom after the main. And then I'm going to actually add the block of code. Oh, it didn't take the V void. The block of code. And I'm going to copy and paste the stuff that I had in the conditional statement. And I'm only going to be bringing in this. So this is the code that I'm going to be putting into that other block. I'm going to Control X for cut. Okay, it's right here. Control V to paste. And now I have this block of code here. I'm going to bring it back a little bit so it's not indented so much, using the Shift tab. Okay, now I have a block of code that that passes in button pressed, and all the zeros in here that you see is going to have to turn into this button pressed variable. This is where it becomes very useful, because now you can start seeing how the next button pressed, the one for port D, can be used in calling this method. So let's go ahead and I'm going to do a copy and paste. I'm going to paste it in here. Anywhere you see a 0, you'd do this. Now we're going to get into a situation where we're going to have to add another conditional statement because I'm using port B near the bottom here, and I'll show you in a second. Let's see. Okay, now this is where it gets tricky. I'm going to go ahead and just do the zeros for right now, and then get to that one. Okay, so we have put the array value in according to what is going to be called. And for the port B, I'm going to say, because this could be port D as well, so I need to specify which one is going to be according to the button pressed. So if button pressed is equal to 0, then I'm going to process this line. I'm just going to put it on the same line since it's only one line. And if button pressed is equal to 1, then it's going to be port D instead. Or shift the LED number. Okay, so now I have it processing the LEDs on the port B side and the port D side depending on the button press variable that was passed in. Now let's go ahead and insert the pressed button into the conditional statement we have above. And we're going to say 0 here. So this is what we're passing in. We're telling the program to go to the procedure called process pressed button. Let me put a uppercase B here, and pass in the number 0 for the button number 0, the one that's located on port B. Now we're going to have to do the same thing to the released button, and we'll have to create a prototype first. So let's go up here and create a prototype for this. Void process released button. We're going to pass in the integer, and I'm going to say button released for this variable. Okay, and do the same thing we did before to create this block of code towards the end. Alright, and now we're going to copy and paste, or cut and paste this information here. So get this information, we're going to cut and then add it into this block here. Do the same thing as we did before, shift tab twice to get it indented correctly. Okay, and then we're going to take the button released and we're going to replace all the zeros. Okay, so now in here I can go ahead and just insert the call released button, and I'm going to be passing in the 0 for the port B side of things. Now all we need to do with this next set of conditions is exactly the same thing, because all we're doing is we're working with port D. So let's go ahead and type in here process pressed button, and we're going to, instead of putting 0 there, we're going to put 1, because we're calling 1 the port D side. And then we're going to do the same thing here, process released button 1. So now we have a way of creating compact code. We're encapsulating it. We're simply saying I want to have a condition of me knowing that the button is pressed. I'm specifying a command called process pressed button, and I'm sending it a 0 because it's the port B side. And then I have another command. If this is not true, then I can process the released button, and we're passing in 0 as well. Now we have to deal with port D, and we're doing the same thing. We're only changing what's in the array, the array container. So we are essentially done with the main processing of it, but we haven't really addressed what happens when they win. And that's the only thing we really have to do now is do something really cool once they win, and then go back to a state of being able to start over again and start pressing the buttons again. So I'm just going to add a for loop, and a for loop is just a loop. Instead of going like the while one the while one that we have in the main is an infinite loop. We want a loop that actually only goes for maybe 10 or 20 times. It processes a set of instructions 20 times. And we're going to use a for loop to do that. We can use a while loop and have an incremental variable inside that while loop, and when the incremental variable becomes true on a particular loop, then it exits that loop. I would rather start with a for loop because that's the most, for me, it's the most compact. I think it's the most compact way of creating a loop. And what we do is we have a variable, we have command is for, and then we have a open and close parentheses, and we have a block of code right underneath it. Inside the parentheses is our condition. First we have to declare a variable, and usually the variable is an integer, and I'm using the integer of I. And we also have to initialize it with some number. If you don't, it's going to give you a warning, but it won't fail. So the program will still work, but it's best to initialize anyway in these for loops. Then we have our condition, our I. I'm going to leave the condition to last. We have the I incrementing one at a time. Every time it goes to the loop, it increments one. We could have also done this. It decrements. If we wanted to go backwards, if let's say we wanted to have the integer I equal to 10 and then we go down to 0, we could do that. But in this case, I'm just going to I'm going to increment it every time it goes through a loop. And then we have to have a condition. This will be alive as long as this condition is true. So I'm going to say as long as I is less than 10, continue to loop and perform these particular variables. I'm going to work with only one port right now, just to make things easier. So I'm just going to have this port blink on and off, and I'm going to have a 10 millisecond blink between them. That's why we kept the delay. So port B, and I'm going to have it equal to 0B, and remember that the pin 7, or the 8th pin, is always going to be 1 because it's always reading the button. Then you have 7 zeros after that. 1, 2, 3, 4, 5, 6, 7. This is turning off every LED, and then we have it delay in milliseconds, and 10 of these milliseconds. And then I'm going to have all the LEDs turn on. Port B is equal to 0B, 1, and then 1's all the way across. So all the LEDs are going to be turning off. It's going to delay 10 milliseconds, turning on, and I'm going to have another delay, 10 milliseconds. Delay. Okay, now we'll have it turning on and off for 10 times, and having a delay between each one at 10 milliseconds. Actually, it may only go 9, but I have a 0 here, so it actually probably will go 10. It's something that trips me up all the time, is how many times the loop will actually happen. And you can always test this by counting the number of times it actually does blink, so you'll know whether it does blink 10 times or 9 times. So let's go ahead, and we need to do this for both port B and for port D. So the variable that we have at our disposal is the button pressed, which is up here, the button pressed variable. So we know what state it's going to be in. So we're going to go ahead and just have an if condition, if button pressed is equal to 1, or 0 actually. Then port B is equal to erasing of the LEDs. But you know what? I found a place where I'm going to be messed up here, tripped up with these double equals. I needed to make those double equals. So let's go ahead and do the same thing. If the button pressed, and then we'll say if it's equal to 1. Let's put it here first, actually. So that would be 0. It always keeps me from getting that first character. So we need to do this for port D. Okay, that's fine. Alright, so if button press is equal to 1, then it's going to be port D instead. Let's do that to this one. Control C, Control V. Alright, button press is equal to 1, and then we'll change this to port D. So they'll both do the same thing. If it's going to be 0, it'll be 0 here as well. So it'll be port B is equal to 0s for the LEDs, then it'll delay, then it'll turn on the LEDs, delay, turn off the LEDs, delay, turn on the LEDs, delay. And if it's 1, if the winner is 1, then it'll do the same. It'll do that for port D only, and it'll delay. We also want to, when we're finished with this, we want to reset the LED number back down to 0, both of them. So the LED number, so we can start all over again. 0 should be equal to 0, and LED number 1 should be equal to 1. Alright, so now we should be pretty much complete with this program. We have taken care of everything. I'm going to go through it one more time. we are including the IO.H, which is standard for all the AVR microcontrollers. We have the delay because we're using that in our winnings. We have our prototypes for the code blocks that we're going to be calling. The compiler needs to know these in the beginning. One for the process pressed button and then one for the process released button. The pressed confidence level for the button debouncing, released confidence level for the button debouncing when you release it. We have a pressed to acknowledge whether it is actually pressed or not, and we can test whether it's gone through the whole process of being released and then pressed again. The LED number, so we know which LED should be lit up. And then we're going into the main subroutine or the main procedure. We're first initializing the ports. We're specifying the data direction, and the number 8 pin is an input, so it's 0, and the rest of them are going to be output. The port B we have as reading high for the 8th pin, and then we have them as 0 or 0 volts, so the LEDs do not light up. And then we have our two conditions, one for the left side or the port B, and then one for the port D or the other set of buttons and LEDs. And we have it calling those two procedures that we've created earlier to make our programming much more compact and easier to read. And then we actually create those procedures, which one is called process pressed button, and we're passing in button pressed. We don't know which button it's pressed, but it will be called correctly once the actual button is pressed. And then we have our standard codes for the button debouncing, getting the samples of the zeros and ones. We have the pressed confidence level for the threshold. Has to be more than 500. We have to have 500 of the zeros or 500 of the ones. The zeros over here and the ones over here, to make sure that we have no bouncing going on. We have to make sure that the button was released before it was pressed, so we can get a toggle on the button. Then we increase this is where all the fun stuff happens. We reset the pressed button to 1, or we set it to 1. Then we have the LED number, we have that incrementing. We actually invoke that to the port B by putting the LED number and shifting it from the 0 bit to the 7th bit. We don't go over the 7th bit because we have this LED number button pressed. If it goes over 6, then it's going to reset that. Oops, look at this. I should have had this as a 0 here. So we're resetting both LED number arrays. Then we have for the winner, because that person got to the greater than 6 before the other person or the other port. I'm going to say that particular person got to the number 6 or bypassed or passed number 6 first. So that particular set of LEDs will go through a loop of 10 blinks, so they know that they won. And then it'll start all over again with the LED at 0. I still need to take this and reset both, because only the one that won will be reset. So I want to make sure both of them are reset. So let me go ahead and make that change. So now we know that the LED numbers are reset, and the port B and D, all the LEDs are turned off. So we can start all over again and see if the other person can win. And then what we did is we created what is a process released button, block of code that can be called, and the variable can be passed in, and we have the release confidence level incremented. We have the threshold here, as we did in the other portion of the program, and then we have it going if it was an actual released, if it had more than 500 good samples of zeros, then we go ahead and make pressed button release 0, and the confidence level does go back down to 0, as it did to the other one. I didn't explain that. So now the program should run. We'll go ahead and do a make and see if we have no errors. Make all. I did see an error. So let's see where this error is. Bring this up. Okay, so it says that on line 24 The error subscripted value is neither array nor pointer. And it looks like it's going to this process pressed button. Let me look at my spelling on that. Process pressed button. Process pressed button. Ah, you know what? I shouldn't have used a bracket. I should have used a parentheses. I've been using too many brackets. Okay. Take those parentheses, put them in there. Okay, now let's try to make it again. Make all. See if it works now. Okay, we still have some errors here. Alright, line 75. Okay, released confidence level. What I did is I made this lowercase. That might make a difference. Let's see, make all. Yeah, I still have that error. Why do I have that error? I completely forgot to do the array for that one. Button released. Okay, so that should be good. Let's go ahead and make all, and then we can program it. I'm pretty confident this will pass and with no errors. Okay, good so far. Okay, so now we need to program it. So go ahead and plug in your circuit into the computer using the programmer, and we'll program. Okay, tools, program. Okay, it programmed successfully, and I will try it to see if it works. All right. Okay, it's programmed. Let's test it and see if it works. Well, it looks like this LED did not light up. Let's try this. Oh, same thing happened. So that means it's consistent, and it's probably within that called block of code. So we do get the blinking on the one that won. So we just got to find out why this particular LED did not light up in the beginning, but it looks like it does light up. But I think that's just part of the winning code. So let's check out why that did not work. Okay, so this is the code block where it increments the LED and where it'll light up the correct LED. And what I have here is I actually have it incrementing first, and then it will show it will process which LED should be turning on. What I need to do is the LED number needs to be starting at 0. It has to start at 0 here because that was the 0th LED. So what we want to do is we want to take this increment piece of code operation, and we want to put it on after it has actually processed which LED should be turning on or not. So let's delete that little space there. Okay, so now it should work. Now let's go ahead and go to Tools, Make All. Make sure we don't have any errors. And now we're going to go to Tools and Program. Okay, now let's see if it works. Okay, this was programmed again. I'm going to focus it on the LEDs and bring it in a little bit so we can see which LED is going on first. Yep, so that worked by switching out the increment to after it set the port pins. Now let's go ahead and try my fingers and see which one's faster. Oh, they're pretty equal. Okay, so I'm going to do a little bit more testing, and that is the way you can create a quick button pressing game using LEDs and button. And you've learned how to create encapsulated code. You've learned arrays, a little bit about variables, and we'll also be getting through the many examples. I'll be giving you more examples on different types of variables. Okay, go. Oh, I got it. I won. Come on, try it again. Oh, I won again. You gotta pick your finger up. Oh, you got it.
I got it.
Yep. All right, try it again.
Wait.
Kiki, come. Yeah. All right, come on. Oh, you got me. Oh, I won. All right. Oh, I won. Come on. Oh, you got a head start. And I still beat you. All right, let's go, Kiki. Oh, I won.
Hey,
Come on, quick.
Faster.
Quick, Kiki, quick. Oh, you got me.
I win.
Yeah. All right, come on.
We both won.
Come on, go.
Wait.
Go. I'll give you a head start. Okay, let me see if I can get. Oh, I got it. I'll let you go halfway, okay? Go. Oh, you got me. Okay, go ahead. Let's do it again.
Okay.
I'll give you your handicap. All right. Oh! All right, do it again. Try to go faster. I got you.
Oh. Let's stop.
All right, you two do it.
Okay, do it. I won.
Oh, come on, go. Kimmy, go.
No.
All right, on your mark, get set. Oh.
No.
Go. All right, go.
Yay.
Yeah. All right. Kids say, thanks for watching.
Thanks for watching.